Today we'll be talking about the structured query language. In this chapter, we will be learning about the basic commands and functions of SQL, how to use the SQL for data administration. This means to create tables, indexes and views, how to use the SQL for data manipulation. This means to add, to modify, delete and retrieve data. And finally, we'll talk about using the SQL to query the database, that is, to send queries to retrieve information. So what is SQL? SQL is a language that allows us to send queries to the database, as well as allows us to create and delete and modify tables into the database. The functions that the SQL has fit into two major categories. The first one is for language for defining the data, and the second one is language for manipulating the data. There is the National Institute, American National Institute, that is handling the SQL, and that it maintains standards for what SQL includes so that it is the same for everyone. Let's look at the data definition commands. When we are creating a table, we need to specify the data types of the attributes, as well as what attributes we'll be using and how many they are. The attributes are the columns onto the table. And then, if we have more tables, we're going to do the same thing for the next table. So in this database, there are several tables: customer, invoice, line, product, and vendor. Let's look at the first one. Let's look at the product table. So here we have the product table on the bottom right, and it is linked to vendor and line. We have been learning about linking the tables using a primary key. So this is an entity relationship diagram that shows the relationship between the tables. The product has a relationship with vendor and line. We can see that the vendors are supplying the products. So if we're to create a product table, it has several attributes. So what we see listed here inside the table are the attribute names. The first one on the top, P code, that's product code, is the primary key. So PK stands for primary key, P code stands for product code, that's a unique identifier for each product. And after that we have the actual attributes for this product. The description, date, minimum, price, discount, and so on. So when we are creating a table, if we're gonna create this product table into the database, there are two tasks that we need to complete. First is we need to create a database structure and then create tables that will hold the user data. So the relational database management system is the software that would provide us management of the database. That is, it stores our tables, allows us to send queries, that it processes the queries and retrieves the answers of the queries for us. It allows us to create and delete tables and to make updates to the tables. There are several relational database management systems that exist. Can anyone give an example of relational database management system?
Professor, MySQL server.
So we have MySQL. Anything else?
PostgreSQL.
Can you type it in the chat?
Please hold on.
Okay. we have PostgreSQL, we have SQL Server. Yeah, so all of these would be relational database management systems. We have Oracle, we have Sybase, and so on. So the database schema would be the structure that we talked about. This schema would identify how many tables we have and what are the data types and the attributes for those tables. Data type selection is usually dictated by the nature of the data and the intended use. Here are several data types that exist with SQL language. So we can tell if the data that we are entering is numeric or if it is, let's say, categorical, for example, some adjective or description. In that case, it's text data. So we can tell if it is numeric, that if it's a number, if it's integer, small integer, or decimal number. Otherwise, if the data is not numeric but it's categorical or it's describing something, then we can say the data is character, variable, or variable character. That is a string of text. We can say if it is a date and time, or a timestamp. Other data types are real, double, and floating point number. And there are many others, but when we are entering the new table into the database, we must specify the data type of the attributes and the attribute names. Once this table is created, we can then load it with data. We can save data inside of the table. So we would use one line per column. We can use spaces to line up attribute characteristics and constraints. The name of the table and the attribute names should be capitalized. The primary key, as we said, is uniquely identifying the objects in particular table. That's why it has the unique specification. It also must not be null. That means it cannot be blank, the primary key. We can have null values, but not for the primary key. So there are these constraints exist in SQL, not no constraint. This means we can set up these constraints for certain data. Not now can be set up for the primary keys and unique as well. That another one is the default constraint will assign value to attribute when a new row is added. If we didn't provide a value, a default value would be assigned. We can set up a check constraint. For the check constraint, when the date is entered, it will validate what is being entered. So let's say we want to enter a credit card. It will validate that we in fact entered a number, and this number is integer and it has 16 digits, to make sure that this is an actual credit card number what we're entering. Okay, so SQL indexes. When primary key is declared, the database management system would automatically create unique index. We can use the create index command for a selected attribute. Okay, so we have been looking at the database schema and data types of how to create database, how to create a table. Now let's look, once the table has already been created, what can we do with the data that is inside the table, or how can we load the data inside the table to begin with. So to load the data, we will use the insert command that allows us to insert data into the table. So let's look at this. Insert into, and then we're going to give the attribute name, and then values, and we give the actual values. And what's very important here is you see this little semicolon at the end that has to be there, or we will get a syntax error. So the SQL statements would end with a semicolon like this, similar to many programming languages like Java and C++. Okay, so insert into the column name the values. Another command is select command. We can select rows from the table. That is, we want to query the table and retrieve certain rows from it. We can use that select command. Alright, again back to the insert. When we're inserting, there are a few things to notice. The contents are enclosed with parentheses, and we have that semicolon at the end. So we have these parentheses right here. That's the actual data that we are entering is gonna be in between those two parentheses. So row contents are entered between the parentheses. The character and data values are entered between apostrophes. So if we are entering characters, they need to be enclosed with apostrophes. like this. Numerical entries don't need these apostrophes, that's just to designate what we're entering is text or strings. Attribute entries are separated by commas. So if we look here, we have these little commas. So this is very specific syntax. It has to be like this. They need to be parentheses around the values, they need to be commas between the values, they need to be a semicolon at the end, and if there are strings, they're enclosed with these apostrophes. So it has to be this way to make sure that it's working. A value is required for each column. So value 1 to n, as many columns as we have, for each one we need to enter a value here. So this is a specific syntax for the SQL that we need to be following. If we make changes to the table, we can use the commit command to make sure that the changes we created are saved. This will permanently save any changes made to the table and in the database. Okay, so going back here, we will now look at the select command. So select is used to list contents of table. Select and then the column name, and then from table name. Basically select from. We can say select star from this table, that's gonna select everything, or we can select specific columns from the table. So if we look here, if we say select star for the product, it will return all of these, the P code, the description, in date, and all of those attributes. Or we can say just select the description. So column list represents one or more attributes, and they need to be separated with commas. The asterisk can be used as a wildcard character. And the next command we have here is the update command. The update command will modify data in the table. We can say update, then give the table name, and then set column name, and give it some expression here. The column name becomes equal to the expression. Let's say we want to change the name of some attribute. We can use this command. More than one attribute can be updated. A rollback command will undo the changes that we saved. It's just rollback and semicolon. Delete commands. We can delete contents. We can delete a table row. We can delete an entire table if we want to. We can delete an entire database. So delete from table name, where, and then we say what exactly do we want to delete. Specific columns or specific values, specific objects from the database. Can delete tables, entire database, specific columns, or objects with certain values. We can insert data into the table, insert into table name, and then we say what we want to insert, and we can also have nested commands like insert into whatever is selected from the following statement. So that's a subquery. The select queries, we can find two select commands by adding restrictions to the search criteria. we can use conditional restrictions, arithmetic operators, or logical operators, or some other special operators that we have. The syntax is like this. Select from the columns. We have to give the column name or a list of columns. We have to give the table name from table. And then where. So select from where. And here we can give the conditionals. For example, we can select all customers of age bigger than 25, for example, or select all students who live in zip codes. So these are examples for conditional statements. This is a visualization of Microsoft Access relational database system. So over here we can send a query. On the right side you can see we have selected SQL view, and we say we would like to view the specific columns of this data table. 1, 2, 3, 4. 4 are selected, and this is a graphical interface that allows us to click on things that actually create the SQL code for us on the bottom. You can see in the bottom it says Microsoft Access generated SQL, and if you look at this, it's just gonna say select, then the column names, product P, product description, product price from the product table where, and then it gives product code is equal to 21344. So basically it will select items with this product code. So that's an example query of how the query looks like, and then once this is run, it will retrieve the data tuple or data object, data role that satisfies the query requirements. So like we said here, we can use arithmetic operators, conditional restrictions, logical operators. So arithmetic operators could be add, subtract, multiply, and divide, for example. Logical operators are OR, AND, XOR, and so on. Logical operators with AND, OR, NOT, and as well as XOR. Special operators, between, check whether attribute values in this between certain range is null. If it is null, check if the value is null. Like will match a particular string pattern. For example, like Angelina, name, customer name is Angelina, or it contains Angelina within the name. And so these are special operators. In is another one, exists is another one. Okay, so we have special operators, logical operators, and arithmetic operators that can be applied to the select command. So the select statement allows to retrieve data that satisfies certain conditions from the table or from the database. and this is for basic SQL, and next time we will continue with the advanced SQL commands.